Hey everyone, and welcome to our Chainlink Substrate workshop, where I will show you how the Chainlink Substrate Pallet works in the Substrate ecosystem. I'm Matt, I work at ChainSafe, and I'm the tech lead for the Substrate Chainlink Pallet. The initial development on this pallet was done by Parity, and we took over a couple months ago, implemented additional features, and we will maintain it for the time being. So if you have any questions or troubles, then please reach out and we will try to get this resolved. And without further ado, I would like to give you first a brief overview about the Chainlink pallet, how it differs from Ethereum, and then we dive directly into the code, and I will show you how to configure it and how to use it. So first things first, the intended functionality of the Substrate pallet is to provide substrate-based chain with the existing Chainlink price feed functionality. And it's designed after the Flux aggregator Solidity contract. And if you don't know, the Flux aggregator contract handles aggregated data that's pushed in from off-chain price feeds and unlocks payment for oracles as they report new values. These oracle submissions are then gathered in so-called rounds, with each round aggregating the submission for each oracle into a single answer that represents the current value of the price. And then this latest aggregated answer is then exposed as well as the historical answers and together with the timestamp. There are some differences if you come from Ethereum, and also the Substrate palette provides a bunch of additional features that are not available out of the box on Ethereum. So forgot to mention this workshop assumes that you're at least to some degree familiar with Substrate pallets. So quick summary is that substrate-based chain consists of a bunch of different pallets, which are basically modules that you can plug in together to form your custom runtime logic. And this Chainlink Substrate pallet basically provides the whole price feed functionality. And the main difference between Ethereum contracts and this pallet is that there are no contracts in vanilla Substrate. So instead, we introduce something called feeds, which are basically the Substrate equivalent of a Solidity contract. You can't deploy feeds into the pallet. Instead, there exists a designated dispatchable call that allows you to create a new feed. I will show you how to use this in a bit, but first I need to mention a bunch of different additional features we have in this palette, which is configurable storage pruning. This allows you to set an optional window where you can allow the chain to purge all values that are not used anymore. That is useful to reduce storage bloat. And also, since this is a pallet, we that focus on-chain interaction. So you can directly interact with this Chainlink pallet via Substrate, via Rust traits, and also via the callback handler, which is a functionality that gets called on every new value on every new answer, and then you can implement your custom logic around that. Before I head over to the code section, I want to highlight the existing Polkadot blog post, which goes over how the Substrate Pallet will fit into the Polkadot and Chainlink ecosystem. You see here the Substrate Pallet is intended to be used by different parachains, and then they can access the Chainlink network. Okay, so this demo I'm giving you, the code demo, will be live on our GitHub repository here. So feel free to try it, and I will give an overview how you can add support for Chainlink, for the Chainlink palette to your runtime, and then use it in the existing Polkadot.js UI. So let's open the IDE. Okay, I hope you can see it okay. So this is completely based on the Substrate node template, and we are in the runtime file. And what we need to do is first define a bunch of different types, an identifier that will be used to identify feeds that we create, and the value type that represents the price value. Then a bunch of different parameter types that, for example, limit the number of oracles one feed can have, or how many feeds can actually exist. As next step, we need to implement the config trait for our runtime. And now we plug in all those different types. And an important part of that is the currency type, which manages the payment for all the oracles and their submissions. In this demo, we will use the standard frame pallet balances. And I mentioned it already, there is something called the on-answer handler that gets called for every new value. And we can implement a custom handler that gets executed for every new round, like this. So we have this on-answer handler trait, and we can implement this for our template module that's included in the Substrate node template. And we modified it with an additional storage map last rounds that simply can store the latest round for every feed. So we can access different pallets here directly and interact with that. So we insert it in the storage map that we then also can query on the UI. Okay, that's about it for adding Chainlink feed support to your custom runtime. I will head over to the UI and show you how to create a feed and submit value. But before that, before we can use the UI, we need to declare our custom Chainlink data types so that the UI knows how to decode our custom types, and these are stored in the types.json. I will copy this real quick so that we can configure it in the runtime. So let's head over to our runtime real quick, to our UI real quick. Forgot to start. Sorry about that. I forgot to actually start the node. So coming back here, I have it compiled already. And to start the node, we need to provide the validator Alice and then enable also cross support so that we can use the UI. So this will boot up the node real quick on port 9944. Nice. So now we can use the UI. Let me head back to the UI. Okay, it's already connected. We will now head to the developer section where we need to add our types I just copied and save them so that the Polkadot.js UI can use our custom types. Okay, nice. To execute extrinsics, we head to the extrinsic section and use Alice as our feed creator because by default, this Alice's permission to create feeds. We select the Chainlink feed palette and we get now an overview of all the available extrinsics. We select create feed. And now we have all the available parameters that are necessary to call the create feed extrinsics, starting with the payments that an Oracle should receive for a valid submission. Then the timeout after which a started round is considered invalid. And then the submission value bounds where the expected submission should be in. For this demo, we will only require one submission to aggregate the answer. And we will set the decimals to 8. Now we need a description. I coded demo as our description to hex. So let's insert this here. And we need also a restart delay, after which we are allowed to start a new round. And now we finally have to add a bunch of oracles that are allowed to submit values. So for this demo, I will use Bob as the oracle and Alice as Bob's admin that will maintain Bob access and stuff like that. Let's add another one, Charlie. These are all the developer accounts that are available by default in local nodes. And let's keep Bob as Charlie's admin. Okay, that's all we have to do to configure the call. We can now sign it and submit it. It should be available real quick. It's included successfully. We can double check in the Explorer section. And there is the corresponding event that the feed was created. So by Alice with the feed ID 0. We can further triple check this in the ChainSafe section and query the actual feeds storage in the Chainlink feed. So in feeds, we can query feed with the identifier 0. And there is our created feed with our correct bounds and also our description. So now that we have feed created, we can head back to the extrinsic sections to submit a new value. And because we added Bob as an oracle, we can use Bob as the submitter and select again the Chainlink feed palette. And now we need the submit extrinsic here. And the submit extrinsic expects the feed identifier, a round ID, since this is the first round we create and submit, will be 1. And we want to add a submission that's submit price value of 100. We can submit this transaction sign it, and wait until it's included successfully. You can again head over to the Explorer to check the events. Here is the first event, it's the submission received event, which gets emitted once Oracle submits a new value. And then is also the answer updated event that gets emitted once the answer was aggregated and finalized, because he only required one submission. This is already available after Bob's submission. And now that we know the answer was updated, we can check our template module state, whether the callback handler was correctly executed. So I went to the ChainState section. Now I'm selecting the template module, and here's already the last round's storage available. Feed ID was 0, and now there should be the last round available. That's exactly right. We have here our submitted value, and the round was started at block 49, and also the last submission was also at block 149 because we only had one submission. Okay. As mentioned, there are a bunch of different extrinsics available here. We can also change the oracles, like adding new oracles with their admin, or also disabling them. And there are lots of maintenance function that I urge you to try out. So this concludes my workshop presentation. And as mentioned, this workshop, the code for this workshop will be live at our ChainSafe repository. And if you have any questions, please reach out, or maybe in the Q&A section. Thank you very much.